This is the 2 p.m. session, and the live stream is now on, so hello if anyone's watching. And this is the session today on digital trace data. You already know me, so I don't need to introduce myself. And the purpose of, so we're going to have two sessions today in the afternoon, and this is the first part of it, when I'm going to talk about digital trace data. And the purpose of this session is really to think about digital trace data broadly, right, as a category of data, and think about its strengths and weaknesses, but also to think about different kinds of research designs that one might use when trying to adopt digital trace data for the purpose of social science research. And in the second part of my session, after the coffee or tea break, I'll talk perhaps a bit about the tools and techniques we might use for using digital trace data, and also then conclude a bit about sort of the wider implications when we think about ethical and access-based limitations to using these kinds of data for social science research. So I want to start off the talk very much by actually at the point where Matt Selganik started yesterday, which is that we're living in the digital age, and the digital age is one where information storage has increased dramatically. There's a lot of data out there in the world, and a lot of it is digital, and there's billions of gigabytes of data, and accompanying that is the fact that there's also a remarkable and exponential increase in computing power that has accompanied this expansion in information storage. And this has now been talked about a lot, and in some sense is the premise for this community gathering here, right? We're living in this digital age, sometimes called the big data era, and I like to think that this big data era here has, certain defining features in relation to the way that data exists in the world now. So of course there's the explosion in the volume of data, which is what I showed in the previous slide, right? We just have a lot more data, and a lot of it is digitally recorded. There's also the idea that the data that are produced have higher velocity, or they have a certain kind of speediness about them that was perhaps not possible in the past with other kinds of data that were available. So Nick earlier today was talking a bit about censuses and how the DRC had the census in 1984. Now 1984 was a long time ago, and lots of things have changed since then. But how do we know about those, and how can we measure those kinds of changes? That temporality, the fact that old data sources, they were big, they had volume. If we think about a census is a very high volume undertaking, right? There's a largeness to it, but they were big and slow. But now potentially we're entering a paradigm where data sources could be both big and fast. So there's that important dimension of velocity here that I think we have to be also mindful of. Another aspect of, I think, which is key to understanding this big data era is what I think of as a diversification of the production of data. So who are the producers of data? It's now not just administrative data or governments or states that are interested in and have a lot of data about people. Companies have a lot of data about people, right? And there's also, in some sense, the diversification of different kinds of agencies that hold data about individuals, have harvested data about individuals. And in some sense, that's what I like to think of as a decentralization of data production. Of course, you hold a lot of data about yourself too, as Nick was showing with location histories, right? Those JSON files, which were sometimes gigabytes. I had disabled my location history because, so I'm not contributing to the big data cause. But at the same time, if you did have your location history, and I had my location history in the past before I disabled it, when it was tracked for about 2 years, it was, I think, 3 gigabytes of information. So it's a lot of information that me as an individual had generated. And that's, in some sense, there's a decentralization of data, which also means that different kinds of people have data about you, but you also have a lot of data about yourself, which can be interesting also to think about from the data production dimension. And there's also the variety of data, right? So while in the past, when social scientists did research, we were often thinking in terms of most quantitative social analysis relied on some kind of rectangular data frame, which had usually some kind of numbers in it, discrete quantities. We now also just have a plethora of data sources. We have images available, we have audio available, we also have text, and Taylor will also talk about text tomorrow, but we have different kinds of data that are being generated and new technologies that are generating data. So we have mobile phones, again, Nick talked about call detail records, which of course are a very kind of novel kind of data source. There's satellite data sources, but there's also the Internet of Things, the fact that there are physical sensors that interact with our everyday world. So we have the Amazon Alexas in the world now that are capturing a lot of information about people's physical environments. Andrew Dilnot, who is the warden of Nuffield College, who is also now the chair of the Geospatial Commission in this country, he likes to use this example, which I think is very pertinent here, is that a lot of cameras are now fitted on cars, right? So all the cars that are driving around on the streets, most of them have some kind of, a lot of them have dash cams, but a lot of them have cameras available, reverse cams and other kinds of cameras available, that actually just if we relied on all of that data that is accumulated from all of these cars, we would know where most of the potholes are in the city of Oxford. And Banbury Road has a lot of them because I commute there every day and it's bad. So we would know that if we had all of this data that was centralized somewhere. And it exists. This is not data that need to be generated. It exists, but it just needs to be sort of in some sense repurposed for this. And I think that's, and this is where I like Matt Salganik's definition, that a lot of the data that exist in this big data era are in some sense ready-made. They're already there in the world, but at the same time, they are not custom made for research, right? So they are ready-made, they exist, but they're not custom made for research. And this is the example, or this is the analogy that he used yesterday, where he said, we have here the urinal that was repurposed as art by Marcel Duchamp, and we have here the elegant, gorgeous David, right? Very much, I mean, no one would say this was a repurposed piece by any means. This was not a piece of marble lying around. This is very much marble that was essentially made pristine by the work of an artist, right? So this is what we live in, a world where we have a lot of these go around, but at the same time, it's very clearly that the urinal is not David, but potentially we also have to find ways to think of the urinal and repurpose it as a work of art. So let's start by thinking about, so I've been talking a lot about, as I said, the proliferation of different kinds of data sources and the fact that we live now in a world where there is data abundance. And today I said I'm going to talk about digital trace data. So what are these digital trace data? So the definition that I like to use for digital trace data, that they're the data byproducts of the digitalization of our lives and the adoption of digital technologies and platforms such as, for example, social media, right? So if we think about them as these data byproducts, we can think of them in different ways. So in one sense, digital trace data are themselves the expression of digital interactions and purely digital phenomenon, right? So if you think about tweeting is a digital thing to do. I don't know if there's a physical equivalent of like writing a 140 character, no one writes notes anymore to anyone which are 140 characters. So there isn't a physical equivalent of tweeting. It's a purely digital phenomenon. However, we can also have in digital byproducts, for example, through the use of sensors like the cams that I was telling you on cameras, or accelerometers in our phones that we carry around with us, that's how those location histories that you were using were generated. They're essentially digital byproducts that are created of actual physical activity. So that's also a type of digital trace. And one unique feature about these kinds of data, and I think this is often used as, in some sense, also as an aspect that is unique about them, is that unlike self-reported measures, right, they're essentially much more behavioral measures. They're actually just capturing activity as it's occurring, which is different from someone telling you that, this morning I went from this place to this place. Your location history will reveal that indirectly. This can also be the case, for example, this aspect of the behavioral aspect about these data can also make them, in a sense, sometimes messier as well. And we'll come back to that when we think about also the weaknesses of these kinds of data sources. So in the next few slides, what I want to do is I want to just give you examples of kind of published papers out there that have tried to use digital trace data. So of course, social media sites is perhaps the most widely known source of digital trace data. And Twitter is something that, or Twitter has been widely, I think, used in social science papers to try and analyze discourses or discussions around events. It's also been used to measure things like public opinion, but it's also been used to forecast elections, for instance. And there's a large literature on forecasting elections using Twitter. It's also been used, and this is actually a unique aspect of Twitter as a social media data source, is perhaps probably the most widely used because it's the most widely accessible. And that is actually becoming, I would say, a little bit more complicated now. There's more authentication processes involved in accessing Twitter data. But one of the reasons why I think Twitter has been so big in the world of social media and computational social science research is partly because it is one of the data sources that researchers can actually access through an API. So this paper here, and one of the authors I note is Pablo Barbera. It's by Jost and colleagues. Pablo Barbera will be speaking next week on Monday, and in the Summer Institute here. What they do is, in this paper, is they essentially are looking at Twitter accounts that were created daily in Ukraine before and after some protests. And they want to essentially look at these peaks around certain key events over the period that they're looking at, and they see that as a form of political mobilization around these time points that are occurring in the real world. So, of course, there can be an active debate about what this really means in terms of, is it a good measure of political mobilization and so on. But the fact that they're capturing these peaks occurring at very, very fine time scales on a weekly basis is quite interesting. Here's another example from a recently published paper in Psychological Science by David Garcia and colleagues. And what they look at is, this is around the time of the Paris terrorist attacks. They look at essentially emotional valence, or they look at discourse in terms of positive and negative sentiments around the times of the attack. And then they try and see sort of this shoot up of the negative sentiment. And they say that we can actually see kind of a public collective emotions through these data sources. And we can, through Twitter, see, in some sense, collective emotion and social resilience occurring in real time. In some of my own work, I've been using the data source that Francesco Rampazzo talked about yesterday, which is the Facebook Marketing API, to nowcast global digital gender gaps. So this is a very important, I would say, social development indicator. It's important for us to know where women have access to internet and mobile phones, and it's actually something that we know remarkably little about, or we don't know as well because of the lack of widespread survey data to measure ICT use by gender of the user, especially in low and middle income countries. So in this context, essentially looking at the number of Facebook users by gender of the user, and as well as other characteristics such as device type or age, can be a useful proxy for capturing digital inequalities, digital gender inequalities, at a very regular basis. So on our website, digitalgendergaps.org, we essentially reissue this map every day because we can query the map we can query the data source very frequently. We can't run a census every day, but we can't definitely run a survey every day, but we can ask the API every day how many men and women are monthly active users or daily active users on Facebook. So those were examples of social media sites. Web search queries have also been used a lot. And I would say these were the kind of earliest examples of digital trace data as being heralded as with a lot of excitement and as being seen as the new telescope with which to view and understand human social behavior. This was a very famous quote in a paper by Duncan Watts, where he said that now we can directly just observe behaviors. So this is the earliest examples of this. So this is a paper by Ginsberg and colleagues published in Nature in 2009, in which they tried to essentially match the estimates, CDC, the Center for Disease Control's estimates of influenza, with Google search queries. Now the black are the Google search queries and the red are the CDC estimates. And you can see the CDC estimates have a bit of a lag, but then Google search helps us predict what's happening, and then the CDC follows and seems to be generally well calibrated to what the search queries predicted. So this was back in 2009 when they first published this, and there was a lot of excitement about the potential of sources such as these web search queries for being able to track and nowcast predict the present essentially of key social development, health, and other indicators. Another aspect of Google search queries, for example, that has also been touted is that they might potentially capture behavior that people might not want to report, right? So they might have the ability to capture phenomena that are prone to social desirability bias, where if we were doing things in the context of a survey, people might not want to report these things. So in some of my work with Nicolo and others, we've been trying to see if we could use Google search queries, for example, to study sex-selective abortion in the context of India, which is a behavior that we know as demographers exists, but of course people don't want to talk about it and report that they're doing it themselves. They might be okay with telling a surveyor that other people are doing it, but they don't want to report their own behavior in relation to these kinds of things. And an earliest example of using Google search to study abortion is Rice and Brownstein in 2010, where you see here on the x-axis, you see proportion of pregnancies ending in abortion, and you look at relative internet search volume for abortion in those countries. And what they argue in this paper is that places where people tend to search for abortion much more are also the places where there are very significant restrictions on abortion. So in some sense, there is actually a demand for this, which is not being met, and people are resorting to the internet and other kinds of resources online to try and seek information about these things. By the way, I should preface my comments by saying that please feel free to ask any questions at any time, or if you want a clarification on something, or even a more substantive question. So another source of data that I've seen being used in the literature is blogs and internet forums. So this is here a paper that looks at how people are providing social support online via Reddit. And they look at different types of support. So they look at whether this is emotional support, is this informational support, and in the paper they describe the other categories of the kinds of support that people are providing on forums on Reddit where people are talking about mental health. And they find that, and they're interested also in how much of this support is kind of done, as anonymously, and how much of it is done non-anonymously. And they find that a lot of emotional support is actually provided anonymously, whereas kind of more practical informational support is provided non-anonymously. Right, and then Nick talked about this already extensively, so I perhaps don't have to dwell so much. But this is again a paper that Matt Salganik talked about yesterday, which is called Detailed Records, to try, and this is again one of the earliest examples or a very well-known paper that tried to do computational social science by leveraging a very novel source of data, at least at that time, which was called Detailed Records. And on the left in panel A, you have the predicted wealth index for districts in Rwanda computed in 2009 using call data, so the CDR data. And on the right-hand side, you have the same, which is estimated using a very high quality but expensive survey, which is the Demographic and Health Survey in Rwanda. Now you see you have sort of correspondence in the colors across the two, so essentially with much less data trained. So this was predicted using matching called the CDRs to a survey in which they could actually verify and validate the information on respondents. So using a much smaller data set, as Matt described yesterday, which was what A relied on relative to the DHS, they were able to generate pretty similar measures. And that's an example of, in some sense, reducing cost, improving frequency of measurement, and potentially also guaranteeing more effective scalability. Right, and the last example I want to use is sensor data, and this is an example of a kind of a sensor data, and this is a paper published by Newing and colleagues, who I believe are actually working on this as a part of the ONS, the Office of National Statistics, big data and official statistics team. And what they try and look at here is electricity smart meters that exist. So this is an example again of these Internet of Things phenomenon. So we have a lot of homes now in the UK have electricity smart meters, and you see that there are these kind of very distinct profiles of household energy consumption that occur, and these vary by kind of the household composition, right? So families that have 2 adults and 3+ children, they tend to have a lot of activity around 5, 6 that time, and then early in the morning as well. They tend to have a lot of activity probably around the time of school. And they make the argument that these electricity smart meters, we have this data, and since we see such clear patterns of consumption based on household characteristics, we could maybe start inferring something about the structure of households in the UK by just looking at electricity consumption itself, rather than waiting for censuses and so on to come around. And this is another example which I like very much, and it exists in, and Matt talks about it in his book, Bit by Bit, which is using essentially the meters in electronic meters in cabs in New York. And what they do is they had information, so this is Farber, he had information on all rides that were taken, I believe. So this is the New York City Taxi and Limousine Company, the agency charged with regulating the industry, now requires all taxis to be equipped with electronic devices that record all trip information, including fares, times, and locations. The currently 2 companies that supply these devices report all this information to the TLC on a regular basis, and I have obtained full information for all trips taken in New York City taxi cabs for the 5 years from 2009 to 2013. And using these data, what Farber then proceeds to do is to actually test 2 competing theories in labor economics, neoclassical versus more behavioral economic approaches. And he tries to see, is it that on days that taxi drivers are getting higher fares, do they work more or do they work less? Because neoclassical economics would tell you they should work more, they're going to earn more, whereas behavioral economics would tell you, well, maybe they just will have a kind of maximum, they want to earn $200 a day, and if they can do it in 3 hours, they'll stop. So what do we find? He actually found that neoclassical approaches better fit the data that he had. But that's exactly taking a very detailed measurement and having a data set with very detailed measurement and just testing a theory with it in a way that was not possible with previous kinds of data sources, because it allowed for greater disaggregation and exploration of heterogeneity. Right. So as I said, I've sort of shown you diverse examples here, and I'll come back to what I think these different kinds of examples are trying to do. But there are definitely some kind of promises that we already see when we see these examples of research of digital trace data in action. So the first, I think, is this, and when I'm going to talk about this, I'm going to rely a lot on bit by bit. So if you haven't read this chapter already, I suggest you read it afterwards. That the first, I think, big promise here is the bigness, right? The fact that there's volume, and in of itself is something that's is bigger, better. I mean, in the context here, I think it's not entirely clear whether that would be necessary to have so much bigger data. But when we have questions surrounding, say, rare events, or where we really want to explore certain forms of heterogeneity, where we might be interested, for example, in disaggregating to a certain geographical or to get some disaggregation by geography or time, there's an argument to be made, I think, that the volume is an asset and a strength. So also from the perspective of velocity, I think the fact that there's higher frequency or more regular measurement can also be, I think, can be seen as a key strength of several sources of digital trace data, and also things that are always on. So if we go back to the Twitter example that I was talking about, right, the fact that this is kind of always on, the fact that Twitter is always on, and you can see these peaks occurring around the time of certain kinds of events. Many times, in the real world, there are natural experiments that occur, but we don't have pre and post. We don't have that perfect data set that we can actually go and observe pre and post and exploit that nice design where we could look at what happened as a result of this. But in this setting, potentially we could use that kind of difference in difference kind of design where we could look at a change occurring. Of course, there might be problems if, for example, the composition of users changed across these time points, and then we might want to think about that, and that's a broader problem of population drift or just drift of these kinds of data sources, and I'll come back to that later. But in general, the fact that there are very few other, most of the time our surveys aren't perfectly calibrated in terms of time to capture some of these events that are occurring in the real world, but maybe this always-on characteristic of some social media data sources could be valuable. And Twitter, I think, here is a good example because unlike other social media APIs, it allows you to at least go back in the past. And it allows you to go back in the past. For example, the Facebook marketing API that I'll talk a little bit later doesn't allow you to go back in the past. So you can look forward, which could be helpful if you identify something that you might want to track over time. But if you wanted to go and see what happened, for example, when Sudan, as we were discussing yesterday, shut off the internet, we might not be able to go back and see how that changed over time, but we potentially could with this data source here. Another aspect is that I think for a lot of digital trace data sources or social media data sources, sometimes there are topics or geographies that we might capture in these data sources that we might not in some others. Another aspect, I think, which can be seen as a promise is that they're, again, non-reactive, so they might capture behavior that might be otherwise difficult to measure. And this was something that I also already talked about in the context of the social desirability bias and Google search and abortion. So if we think about here, as I was saying, again, coming back to the gender gaps in internet use when they're being computed here using the Facebook ad audience estimates. So what we see here is that there are some parts of the world, so this ratio is a female to male ratio, is a female to male ratio, so higher values correspond to greater gender equality in internet use. So essentially a lower value corresponds to women being less represented online. And we see that in parts of Southern Asia, here and also in sub-Saharan Africa, we have significant gender inequality online. Now this is interesting I think for a number of reasons. I mean, the first reason it's interesting is that if being online, if the internet is a valuable way to access information, to be able to access other kinds of resources that are relevant to people's health, education, say access to contraception, if women aren't online, if they're systematically less online, it's important for us to know that. And we might not know that if we just were relying on survey data to be able to measure that. So in of itself, I think there's intrinsic value in mapping and capturing this development indicator. But I think another important aspect of trying to understand who is online and who's not online and who is captured in this case, this social media data source, is that if we want to use this, especially to make kind of wider claims about and we want to think about issues such as who is represented, who is not represented, then the fact that women are significantly underrepresented in some parts of the world on Facebook is important also for us to know when we want to use these kinds of data sources for the kinds of research questions we may have. Now, this might not be a problem, again, if our research question pertains in a more kind of difference in difference kind of design, and our research question is how does censorship affect women's internet access? Maybe if we felt that this sample was fairly stable over time in terms of its composition, maybe we could study that using this data source. But if we wanted to say what is, for example, the population level estimate for a particular indicator of interest, we might want to take a step back and think about, well, who are we capturing and who are we not capturing? The same Facebook marketing API has been used by a number of, actually, it's probably the most, there's a question, yeah.
Yes, sorry. So in the previous map, you could put, so if I understood correctly yesterday from Francesco's presentation, you could potentially estimate this as well, even lower, right?
Yes.
Like zip code.
Yeah.
Level.
Yeah.
I mean, this makes sense, right? Because in certain countries, you might have 0 people in certain zip codes, right? So, but potentially this.
Yeah, absolutely. Yeah, exactly. I mean, the reason why I'm showing this map is because first, in order to understand the value of these data, the first step that we undertook was we collected and we created what was a measure of just a female to male ratio of Facebook users. And then we tried to test and validate it against survey-based measures of internet use based from sort of more trustworthy probability sample surveys. And we found that the correlation was about 0.8, right? So it was pretty good. And the purpose here was similar to the Blumenstock paper to say that we have a smaller data set where we have both Facebook and we have Facebook as well as a survey-based measure. And let's just sort of train a simple model to make a prediction then and expand our geographical coverage to those that we don't actually have this indicator for. So in some other work, we've tried to now go down subnationally, but then a limitation there we have is we can measure Facebook use at the subnational level, but of course we don't have good survey data to be able to capture exactly what it is. Right. So we might use it in a different kind of way, of course. But the purpose here was to try and, so this is being done in the context of a project where the UN Foundation, where we got a grant from the UN Foundation to try and see the value of big data sources to measure development indicators. So in that context, it was first done trying to see where we had both data sources and to test the sort of validity of the online data source. Yeah.
So I have a question with respect to, like, if you look at back at the Rwanda example, but also like what you were saying about the fact that correlation is like 0.8 and like it's pretty good, but it's not perfect, right? Yeah. And I think like for some applications of like digital trace data, like elections come to mind. Like there's always like the difference between having a 7% absolute error and having a 4% or 3% absolute error is massive, and it makes all the difference for the people that want to use the data. So what would you say to like a critic that says, well, this is very interesting, very innovative, but there's no way this is useful at the moment?
So I think Roberto's point about how much error can we tolerate is a valid one, and I think it's very context and domain specific. So as again, this is something that Nick was talking about earlier today, when we were actually interested in thinking about does this mean that we have to use a different quantity of spray altogether because the difference between because the differences hinge on like the second decimal point? Then yes, perhaps we might want to be cautious as well, and we might then want to try and think about how these could, for example, be validated against. Or how we might just want to do a survey, right? We might just want to do a survey and actually so run a survey instead. But I think like in the context of some things where we, like I would say in this context, we're interested in just simply mapping inequalities and actually showing that there are parts of the world where this inequality wasn't something that people were really aware about before. And this is an aspect that I think people can still draw attention to. So we're not saying here that we shouldn't do any ICT surveys. We're just saying that, look, if you did an ICT survey, you'd realize that there's there might be some issues here in other parts, not just the countries for which we have these handful of surveys available. So it could be useful as a first step towards drawing attention to a matter, and then saying that while we can't be precise, we can at least still orient the discussion around it. So yeah, your point is well taken, that error is, the extent of error that we can tolerate is domain specific, but I think there still may be value depending on what your goal is. So this is another example of, I think, the burgeoning field of digital demography, where Emilio Zagani, who is the director of the Max Planck Institute of Demography in Rostock in Germany, where he and his colleagues have also been trying to use the same Facebook marketing API, which provides essentially information on aggregate counts of Facebook users broken down by different kinds of characteristics. So they've been using the category of expats, and they've been trying to see if how well they this category of expats as inferred by Facebook can help us track stocks of migrants in different parts of the world. And also in this paper, they look at the US in particular, in different states, and compare their estimates to ACS, the American Community Survey's estimates. So what you see here is just the log fraction of immigrants for a particular country, and Facebook seems to be fairly strongly correlated with the fraction of immigrants according to the World Bank. And they, again, similar to the argument that I was making in the previous slide in relation to gender gaps, we should be able to, migration data and demography are, in fact, of the three demographic processes, births, deaths, and mobility, migration is the worst in terms of our ability to measure it. Even in high-income countries, migration or mobility isn't as well tracked as vital registration is able to track births and deaths. So they were making the argument that at least in between years, when, for example, other data sources might not be available, this could be a data innovation that might help fill this data gap. Right, so the kind of timeliness and the coverage of these topics could be valuable here. So I was talking a bit about also this, what I said is the non-reactivity. So this is a paper by Stevens Davidowitz in the Journal of Public Economics. And what he's looking at here, this is from Google Trends, is looking at searches for the N-word in the US. And so he looks at this and he says this is a measure of racial bias. And then he makes an argument in this paper that essentially, if we just looked at surveys, we underestimate how much racism cost Obama the election. Because, and he puts in I mean, I suggest you read the paper. I don't know it that well. But the argument in the paper is effectively is that if we actually put in and we look at this racial this racial search term, it actually is very highly predictive of the Obama's vote share lost. And so he makes the argument that this is exactly the kind of measure that we would not capture in a survey, and we would not, and he makes the argument, of course, that we are not in a post-racial world, but this is exactly the kind of non-reactive measure that perhaps is free of social desirability bias that might enable us to capture a phenomenon that we might not capture in survey research. So those were the promises. So what are the pitfalls now of digital trace data? So I think one key aspect about working with and using digital trace data are that they're quite, they're quite dirty. And this is dirty in the sense of whether you're using social media data or whether you're also dealing with sensor-based data from different kinds of instruments out there in the world, or if you're using accelerometers. So a year ago, or about 2 years ago, I was a subject in a study. I was contributing to science by being a subject, and I was a subject in a study at the John Radcliffe Hospital in Oxford, and I had a number of measurements that were taken of me. I mean, I think too many measurements, like they created too many variables. At some point I wondered what they would do with so many variables. But anyway, they collected a lot of information from me. And They gave me a fitness tracker. They gave me a blood pressure monitor that I had that would just buzz every hour, just automatically. Just the cuff would swell up, and I would just be being measured. So I was essentially for over a year. I had. I mean, the blood pressure monitor was only like for 3 or 4 days in the year, but I had a fitness tracker for a full year that they were monitoring information from. And then on my final visit to them, I went to them and I said, how much of the data do you think, have you found anything interesting, or do you think, they're like, well, actually, like half the people didn't switch on their fitness trackers. I was like, okay, that's not helpful. But I was like, no, but I've been using mine, so I'm sure some people have been using it. They're like, yeah, but about basically so far we've deduced that about 60 to 65% of our data are just completely unusable. Now, and this is a genuine concern that I think a lot of studies that are trying to adopt novel forms of measurement are going to face, in that a lot of the data that they collect might not be usable because the switching was, people didn't put the right thing on, or there was just too much noise in it that it made it hard to parse properly. But I think this is an aspect of data collection that you have to be mindful of when trying to use digital trace data sources. Another aspect, and I think this is something that we perhaps should collectively, I think, as a computational social science community, need to think about and have a broader public discussion about, is the inaccessibility of a lot of interesting and meaningful digital trace data sources. Now, Nick earlier in the morning talked a lot about call detail records, and then I think Chris asked a question about, well, how accessible are these data? Because there isn't really and perhaps rightfully so, people's information on calls are not being shared widely through some kind of open access public infrastructure. So a lot of existing data sources that are held by private companies but are also held by governments are not really accessible to researchers. And part of that, especially when we think about it from the purpose of companies, is that they just have very different incentives and goals to most social researchers, right? Their goals are often business and profit, and they're interested in generating products that appeal to customers and make sure that their customers don't get angry with them about. And to protect themselves against backlash, especially in the aftermath of events such as February last year with Cambridge Analytica, often companies will restrict access and make it harder to access data sources. Now, there are some well-known leaks. I think Matt yesterday already talked about the emotional contagion experiment. There's also the example of AOL providing access to browser to search histories of people, and then they had made a claim that it was perfectly anonymized, but then turned out that there were some people who could be identified, and this essentially resulted in very senior officials losing their jobs at AOL as a result of that. So it's a business that essentially not only lost business, not only generated a lot of public backlash, but also effectively made it more inward-looking in relation to data accessibility and sharing in the aftermath of this event. There's also another example which Matt talks about in his book, which is the Netflix. In the course of the Netflix challenge, there were a lot of so it was a challenge in which a large data set of what films people watched was revealed. And Netflix essentially wanted to improve its recommender system so that people could predict just people's viewing, just what films they might want to watch better. So it was a kind of it was using the common task framework, this machine learning challenge where people could make a prediction. And then later on, a lawsuit was filed against Netflix because it emerged later on that specific individuals could be identified through their film watching habits. Now you would think, why is it sensitive? It's just films, right, that people watch. Why should people care about I mean, do you care if someone watches your films or someone knows what films you're watching? Well, for some people, this might be sensitive information, right? And it's hard for us to predict what might be sensitive for some people and what might not be so sensitive for others. So the lawsuit was brought forward by a lesbian woman who said that actually the kinds of films that people watch reveal intimate things about their identities and things that they might not want other people to know about, especially if they belong to certain families that might not accept them for this. So I think, from one perspective, you think, this is films, why should we care? But for some people, that might be highly sensitive information. And I guess your ethics activity perhaps gave you a sense of that people might have contrasting perspective on what is valuable and what is not. Yeah, there's a question.
I was just wondering, do you think that in the long term, it might be that actually all this company will restrict more and more, and actually maybe it will be impossible to do online data? That was my feeling when I saw these stories, that it seems to have opened up.
Yeah.
And now companies have realized.
Yeah, I mean, I think that's a genuine. So this is something that Dean Finlon. He's a community. Yeah, Finlon. He says that we're now living in a post-API age, where in the early 2000s we saw this big proliferation of web resources that researchers were given access to, but at the same time, now we actually see that they're clamping down and restricting what's available, and I think that it's one of the challenges with this is that, as I was saying, that we have a very limited understanding so far of what people's notions and conceptions of privacy are. Now you think that on one side, we live increasingly our worlds online, and we have accounts for different things, and we share a lot of information online. But it turns out that actually people still have certain kinds of norms and notions of privacy associated with even that kind of life online, where there's sharing that's occurring online. And trying to find in that kind of and parse out what is sensitive and what people consider to be things that they would like consent before they're used is challenging. But that being said, I think there's also on the other end like this kind of, and this is of the wider discussion about a lot of these data could also be put to good public use in terms of understanding phenomena that we might not necessarily know very much about, for maybe mapping, as Nick was showing, malaria movement, mobility. So trying to find the balance between sort of good public use, but at the same time recognizing issues such as privacy, and also recognizing the importance of what people find to be sensitive information is something that I don't think we have a good answer to at the moment, but we need to have a bigger public discussion about in any way.
A lot of the study, some of them would be, even the one you showed now, would not be possible to do like today compared to like.
I think all of the studies, I intentionally chose them because I think it would still be possible to do them. Yeah. I intentionally chose these examples because they're using data sources that are still, they might be, like for example with Twitter, you might still, there's a more detailed credentialing process now where you have to write about why you want to access these data, but the Twitter API is still accessible. So I think all of these data sources, it would be possible to do this research, at least to this date, right? A lot of these are also aggregated. So search volumes are aggregated. So anyway, but that was intentionally part of my reason. But I think the inaccessibility problem is still the call detail records are inaccessible to a public researcher. But if you have a relationship and then you can sign an agreement with a mobile phone provider and potentially within the context of a project could leverage some of those data. So I already talked a bit about the sensitivity aspect. There's also the aspect of incomplete. And I think with most digital data sources, you're never going to have everything. So because again, they're not custom made for research, so we won't know, for instance, the demographic characteristics of our users. I've seen obviously papers that will still infer those using some existing classifiers or algorithms. So they'll try and infer people's, for example, gender or their race or their ethnicity by looking at images and so on and so forth. And I think those are also important ethical questions about whether we should be doing that. But that's an aspect of the fact that they're incomplete. And we could try and overcome some issues of incompleteness by doing things that then might be sensitive. So, there's tensions there that I think are important to bear in mind. I already talked a bit about this, but there's the issue of data sources being non-representative. Now, in of itself, as I said, whether something is non-representative depends, and whether that's a problem depends on your research question, right? And what exactly it is that you're hoping to answer. And there are maybe ways around it, as Roberto will talk about on Friday, and also Matt will talk on the live stream on Thursday. But at the same time, I don't think that in of itself, we just because something is non-representative, we shouldn't use it. So this is an example here of, again, coming back to the using Facebook to monitor stocks of migrants example by Emilio Zagani and colleagues. And one interesting aspect of this here is that they use this behavior or this category that Facebook classifies people as expats, whether someone is an expat or not. So you can, for example, go and see what Facebook classifies you as in relation to your what kind of ads you should be seeing based on what Facebook has inferred about you or you've reported to Facebook. And if you're interested, later on I can share a link for that. But what's interesting here is that they're using this category of expat, but we don't really know what exactly or who exactly is an expat or how that's been inferred. And that's in some sense behind this. It's a sort of a black box algorithm, because this is not a survey. We don't really have kind of an extensive metadata about it in relation to knowing who is or how this category is defined, and how potentially it might change over time. So if we think about how it might change over time, that's where I think thinking about drift or population drift and usage drift is really important. So the composition of users on these platforms might change over time, and that might have implications for what it is that we are potentially measuring. But also the system itself might change over time, because these are businesses that have different rationale and motivations. So if they have, for example, they might implement an improvement in an algorithm, which might not be great from a social research perspective because it messes up the measurement, but it might make them millions of dollars. So then, hey, who's complaining? So there's trade-offs here in terms of what there's tensions between what often the goals of businesses are and what the goals of, I think, researchers are. And I think this was very nicely exemplified by the Google flu example. So I first showed you the Ginsberg and colleagues paper from 2009, where we had Google flu effectively being matched then 2 weeks later or a month later by the CDC estimates, and Google flu was doing really well with the prediction. Then, and this became such a sort of an exciting project that Google even had an in-house team running its Google flu trends. So they were trying to match and predict CDC estimates of influenza before the CDC, or they were trying to predict the levels of the flu before the CDC estimates came about. But then sometime around 2012, we started seeing that actually Google was significantly over-predicting flu, almost double the CDC estimates, and it started estimating flu to be much higher than it actually was over the course of over the rest of the year. So why is it that this even happened, right? And David Lazar and colleagues have a very interesting paper where they try and diagnose some of these problems. It's actually probably one of the more well-known papers in this literature, The Parable of Google Flu, published in Science in 2014. And one of the things that happened, so to think back to the idea of drift, so if we think about platform drift, in 2011, Google made changes to its search algorithm so that people were essentially told that if you're searching for a cough or a cold, you might be interested in the flu, or you might be interested in something else. So essentially we had an algorithm that encouraged certain kinds of search behavior and pushed people to move to different kinds of terms, irrespective of whether they actually had the flu or not. So that's an example of kind of essentially algorithmic or the system changing that's creating a drift that might make measurement a little bit trickier. Right, so what I've talked about so far is I've talked a bit about the notion that digital trace data sources, they exist, but they have promises and they have pitfalls. And I've talked a bit about some of these shortcomings in the context of some of the papers that have been published in this literature. But I think if we think about what are the kinds of approaches that people are adopting when they're using some form of digital trace data to answer social research questions, I see them in some sense as like three categories of research projects. So the first of this is what I see as measurement papers. Papers that use different forms of digital trace data for operationalizing constructs. Often they're trying to operationalize constructs at the macro level because they believe that this is able to provide valuable information that might not be captured in other data sources. So if you think back to the Garcia paper about collective sentiment in the aftermath of a terrorist attack, they're implicitly relying on the notion here that they're able to capture this kind of macro level collective sentiment through Twitter in a way that might not be captured in another way. There are a number of papers that have tried to see if can we measure mood or sentiment for populations through Twitter. And I think implicitly the rationale there is that we're capturing and we're operationalizing some kind of macro level construct that we might not be able to in another setting. I think another aspect or another way of thinking about the measurement or the use of these data sources for the purposes of measurement in relation to what's already out there in the literature is that these data sources have been used a lot for nowcasting and for filling data gaps. Now the Google flu example is an example of that, where they're trying to nowcast levels of the flu, essentially beat official statistics that are published because official statistics come with a lag. So we're trying to essentially predict the present, as Halverian called it, because there will be unofficial or more conventional data sources an inevitable lag that we won't know about what's happened until it's happened. And in that aspect, I think the nowcasting phenomenon has been done in relation to health surveillance and in the public health literature. It's also been done, or that's kind of the rationale also behind our work in digital gender gaps, is that we're trying to say what's happening now in relation to digital gender inequalities. I also see that as a rationale behind work in digital demography that's trying to examine levels of migration or stocks of migrants. And I think one thing that, if anything, I've learned from this kind of measurement exercise or trying to use these data sources for measurement is that to motivate them for measurement, we always have to justify what we're gaining by using them. Kind of similar to what Roberto was asking before, we have to think about what is it that, what do we gain from using this that we might not gain if we were not using this. So I like to think of that as comparing against an offline benchmark. So in some of our digital gender gaps work, one of the things that we often tried to do was we tried to say, what if we didn't have the Facebook data, and we tried to make some kind of a prediction model just to predict digital gender inequality by some other information that we have on some other development indicators. How well would we do with that? And then we compare it with what we do with just Facebook, And then we try and have a hybrid approach where we combine measures from Facebook with those that are available from other kinds of survey data sources or other kinds of development indicators. So either finding a way to compare against an offline benchmark or have some kind of a hybrid approach might be valuable also to motivate why this work is useful and important. I also see, for example, that is a shortcoming of the original Google flu paper, in that in the paper, if you read the 2009 paper, they sort of say, Google flu, we can predict flu really well with Google, but actually they don't compare themselves at all with a simple time series model where they just use lag 1 and lag 2, right? They're not doing anything where we could actually just look at the past flu to predict the current flu. And why don't we do that? Instead, why do we have to, do pyrotechnics with Google instead? And then, and one way to, again, justify your research, if you were interested in measurement or nowcasting, would be to say, well, actually there are some pros and there are some cons of these data sources, and by doing a comparison explicitly against some kind of an offline benchmark or some other kind of model, I think we can, in some sense, rationalize our approach and say that there are some things that are potentially gained from this. Another line of research that I think or I see emerging with the use of digital trace data are papers that see digital platforms themselves as microcosms of society. So as life is a lot of life is, there are purely digital phenomena, as I was talking about before. Could we potentially think of digital spaces as microcosms of societies to go and test certain kinds of theories that we may have? So I think there was an example in one of the lightning talks yesterday, which was using the moral foundation. I think it was Rishabh who was talking about the moral foundations theory, and that's kind of, to me, an example of thinking of Twitter as a kind of a digital space where we might test a theory about how is it that people's moral intuitions are configured, and perhaps you might have a theory that you might want to take and test into a digital space yourself and think about how that might play out. And I think the third strand of papers, as I see it, that try and leverage different kinds of digital trace data are those that actually are interested in thinking about the implications of digital technologies for social processes. Now, this is something that I myself am very interested in. I'm very interested in thinking about, for example, how now that we are measuring gender inequalities in internet and mobile phone access, what do they actually mean for the attainment of other social development outcomes, such as information and access to contraception, such as access to information about HIV and antenatal screening. These might be examples of how access to digital technology empowers or provides new forms of resources and information that could, have implications for how the world works and for other kinds of social inequalities. And I think this is something that a lot of, at least I can speak more for demographers and sociologists and less for other disciplines, and I know you are from many different disciplines, so I don't want to overstep my claims, but I do want to say that I think a lot of social scientists a lot of sociologists and demographers haven't thought about digital inequality enough. They haven't thought about its implications for other forms of social inequality, for processes of potentially social stratification. And I think that's a dimension where different conversations need to be had, and potentially the use of digital trace data could be helpful in that regard. Is that a question or no? Yeah. All right.
I do have a question. It's actually like an observation, and I want to hear your comments because it's something I'm slightly worried about. So when you use traditional surveys, right, any type of surveys, you usually have a lot of documentation on how the data was gathered, right? You usually have this technical documentation that says if something came up in the data collection process, or why there's an anomaly in a question, and so on and so forth. And so that's good because when you're analyzing the data or exploring it, you can actually explain why you see stuff that doesn't make sense.
Yeah.
But then we don't have that when we're analyzing sort of most social media data or digital trace data that we use, because, for example, when we're using Facebook data, Twitter data, the absence of something might be telling.
Yeah.
Or whether there's a column which means something that we're not clearly,
yeah.
We don't clearly know what everything is about, and we can't really know how the data was gathered in some sense. And so I was just thinking whether we should start to uphold some sort of standards in terms of which data we use, and whether we should have further information.
Or what we expect of private companies, right?
Yeah.
I mean, I think this ties in also with something what Giacomo was saying earlier, that, we have in some sense the issues of accessibility, but I think to some extent we have, you're right, it's not a survey, it's not meant to be used in the same way as a survey. And in fact, in my own experiences, so in the work that I've been doing with the Facebook Marketing API, one of the resistance or one common complaint that we often encounter from Facebook is that they don't, so we describe the Facebook Marketing API as providing a digital census of the Facebook population. They dislike that phrase, right? They say we don't want to be seen as a digital census because we are not that. We are providing our targets for advertisers, and that's what we care about. And I think so. There's definitely a tension there that we might not know what we're measuring because of the lack of appropriate metadata, or we might not have information. But at the same time, I think rather than saying we shouldn't be using them, I think we should be saying we should be using them, and then asking for clarity from the providers of these data by motivating their importance for research. And I think that could be that's I think something that needs to be for me the way forward. Now there are some frameworks out there. Taylor, do you have something to say on this? Yeah, I mean there are some kind of attempts to try and do this now, such as the social science 1 framework. This kind of attempt at trying to form a partnership between academia and sort of private companies. And there are dimensions of, there's also the Open Algorithms project, OPAL, in MIT, that is trying to create a kind of a secure data infrastructure so that other kinds of users might also be able to use anonymized call detail records beyond just kind of small projects that are very specific to specific individuals. So these kinds of partnerships, there is an attempt now, I think, to try and have this discussion and move forward in that space. But I think it's still early stages, and often it's hampered by events such as Cambridge Analytica, which completely pivot the dialogue in a very different direction. And I think that's kind of the challenge. All the discussion then is about misuse, that we forget about the misuse as a result. So anyway, sorry, Taylor, you had something to say.
I was just going to say, there's the step of how the data is created, maybe within the company or wherever.
Yeah.
Logs or something that we're gathering from. And then there's the step of us as researchers, which I think in the computational, at least computational sociology, but really computational social science more broadly, we don't have these standards of how to report with this sort of data yet.
Yeah.
And I wanted to come up with something like if anyone's familiar with like Consort or something, when you're reviewing a kind of a randomized control trial or something, the type of stuff, what should be there in order to say that it was a well done and well reported study that's transparent. And I've pushed back. Well, in fact, just the other day I got back an article that I had reviewed that got R&R'd, and I had pushed the authors to try and be a bit more transparent about their steps, about the parameter selection process, which we just don't have a norm for reporting these sort of things. And their response is, well, nobody else does that. And so I think that I was setting the bar too high for them because nobody else has to do that. And at some point it has to, there is the company side of it, but there's also just us. We don't have a rubric for what we should report in terms of code book or anything like that.
I mean, there's also legitimate tensions here in relation to, so there were some messages on Slack earlier about reproducibility and openness, and while I think as a community we have to be moving in that direction, I think there are tensions between if we're using private company data about what we can actually publish and reveal online. I mean, for example, this was an explicit decision when we put up digitalgendergaps.org online. we were told that we shouldn't be releasing the raw counts from Facebook online. We should only be producing model estimates and putting those online. Because there is and we've had discussions with Facebook as a result of that about what it is that, they're okay with us kind of sharing and whatnot. And I think that then also, there's a tension then, because if we want to be open and reproducible and we want other people to be able to do what we're doing, but at the same time we're not able to provide the data, then we can't also advance in that agenda in the same way. This is not related to digital trace data, but I know some of you have also expressed an interest in agent-based modeling. And in agent-based modeling, there's been this interesting movement towards adopting the ODD protocol, or I'm now forgetting what the ODD stands for, but it's a rubric for actually what, when you're writing up and describing an agent-based model, what you should be looking to very clearly define. And I think that's that kind of a rubric which emerged because one of the big critiques of agent-based modeling initially was that people can model whatever they want, and they can just put whatever they want in a system and then recreate and generate any pattern and say that this theory works. And this was a big critique of kind of the fact that there was just this unstructured Wild West style of ABM programming that was going on. And one response to that was, let's generate a set of protocols about what needs to be reported, how it needs to be documented. And I think, we could potentially move in that direction with this too.
Someone can come up with a protocol.
Yeah, that could be actually a very useful thing, especially in relation to thinking about also from an ethics perspective. Yeah.
So I have a question about so the bigger problem with this specific type of data is obviously that if you take a sample on a certain day and then 2 months later it could be a completely different sample.
Yeah, that's the drift problem. Yeah,
the drift. It's also, especially with the marketing, has to do with the algorithms. If there are multiple advertising at the same time, etc.
Yeah.
So a relatively simple check would just be if you have to run the same collection process 3 times in 3 months at a random moment.
Yeah.
You have to bounce it just too far off.
Yeah.
It's automatic, right?
Yeah, or you might want to think about again, it would probably be very specific to what kind of question you have and what kind of yeah. But if you have a lot of variability, I mean, you notice that counts will change if you query. So, for example, again, with our Facebook marketing API work, we find that the daily active users changes a lot, but the monthly active users tend to be much more flexible. But one of the attempts at the back end of the project is also by collecting the data every day to actually be able to understand what it is that changes and how it changes. Because I think often most researchers who are using these kinds of data sources will use them once, or they'll use them as a one-off collection, and then they won't want to necessarily go and think about it in a kind of a longer term perspective. But when they do want to use it, you're right that they have to think a little bit more about what would be the drift affecting them.
Because I'm missing in this drift argument the marketplace nature of this, because I've worked myself for a marketplace online, and you can target, but then within the targeting, there's a lot of, obviously, how much people are targeting at the same time defines who gets reached.
Yeah.
But also every second, third iteration, they still use bigger same group, obviously, so they can direct, right?
Yeah.
So, which is much more short-term drift, right?
Yeah.
So population drift, I can see.
Yeah.
Maybe you get some estimates, but this type of drift, or looking for confounding, is much more serious.
Yeah. Yeah. I mean, that would just be you mean the platform just changing?
Yeah, but also, I mean, if Nike's also starting to do an advertisement in the same group, right? What's the effect on the way your group gets
because you don't know about the other kinds of,
exactly. And also Facebook knows who is interacting with your advertisement and is using their models to, better. So it's,
No, I mean, I think there are definitely, there's that dimension of the unknown as well, where the algorithm itself from the company side could be changing, but the environment in which, you might be putting up and, but yeah, I mean, I think these are in some sense, the kinds of issues that I'm raising are very general, but you might have very specific kinds of issues in relation to a specific project that would then come about too. So those are what I said were kind of designs that are essentially designs that rely on digital trace data in of themselves. sometimes in combination with other kinds of existing observational or survey data sources. But I think the way forward, and this is, I think, an argument that Chris Bale makes very actively in the context of SICSS, and he actually has a so I would recommend you go look at his he has a tutorial or some slides in which he makes the argument for hybrid research designs that I think may be the way forward for answering some questions also with digital trace data. So the first example, of course, and this is something that's already come up, I've noticed a few times, is how could we combine digital trace data with conventional data sources like surveys? So there was someone, I think Clemens yesterday, who in a sense is doing, or you relying on a data set that does that, where within the context of a survey, there are browser histories that are embedded in them. And then he's also using both, he has information from both the survey and the browser history, and is using that to sort of answer a question. And that, I think, could be a great way forward, where if we are sort of designing or piloting a survey, we ask also to have different kinds of measures, potentially things such as browsing history is one example, but also we might want to share information from our social media pages. We might want to put our Twitter handles available to someone who's doing a survey, depending on what our questions are. So I think that could be a hybrid research design that could work particularly well and might help overcome some of the weaknesses that I talked about. Apps for data generation and extraction. Now I know Chris is, and I think Taylor, you as well worked on the project with the social media apps. So I think Taylor is a good person to talk about how social media apps could potentially be used both as a way to collect information in a way that is ethically sound, so not repeating Cambridge Analytica. And that, I think, is an aspect of ways in which digital trace data could be used in a kind of hybrid design that I think would also work and well. I think while in the past, like the idea that you might design an app was quite forbidding. I know. I think I think Aiden is designing an app, right? I don't know what platform you're using, but in the context of R Shiny, making apps has become much easier now, and deploying them to web interfaces has become much easier. And there are some really good tutorials online on R Shiny if you're interested in that. But I think that could be a model where the barrier to entry has, I think, become much lower than it was in the past. And designing apps could be a way forward for some kinds of hybrid research designs. And on Saturday, we'll also talk a bit about how we might use bots, basically automated accounts that might, say, tweet certain kinds of messages at regular intervals in the context of, say, an experimental design, if you were interested in, say, looking at political opinion formation or things like political polarization. And that is an example again of what is a hybrid research design. With all of these questions, of course, right, or these kinds of designs, we always have to think about some of these designs might be quite new, and maybe there might not be a precedent in relation to them in your ethics board in the university that you're working at. So you might want to probably take a higher standard and think about, well, what are we doing? Is that ethical? And how would someone view this maybe a few years from now? So you might want to adopt a standard which is perhaps maybe more critical and think about for example, if you were using a bot, how is this? Under what circumstances is it okay to use a bot? Is it not? Anyway, so this is what I'm going to end on for this session. We're going to have a break until 3:45, and then we'll come back and do part 2 of this session. So yeah, for now it's a break, and I'm going to terminate the live stream.